Greetings, math fans. All right, so this is day 10, and we're talking about the slope of a curve at a point. Okay, so let's first of all, let's just sketch a picture here. We kind of recognize this picture from the other day when we did average rate of change. And I'm going to pick a point here. This is value of A. And this is going to be point P. And we're going to call this A comma F of A. Okay, then we're going to pick this point right here. And this is going to be Q. And it's going to be, let's call this A plus H. So this distance here is going to be H. And so we're going to call this A plus H, right? That's our X value, comma, F of A plus H. All right, this function is actually y equals f of x, just some function. So again, that distance is H, this distance right here. Okay, that's just subtracting the y values. So it's f of A plus H minus f of A. All right, so let's talk a little bit about the slope. So m is the slope. If I find the slope of that, well, I can either subtract those points or I can just use rise over run, right? And so, right, this is our rise and this is our run. So I have f of, and I'm going to just put this in here, f of A plus H minus f of A, just the way it is, over A plus H minus A. All right, so of course the bottom can be simplified a little bit, and we're just going to get f of A plus H minus f of A all over the A's cancel, we just have H. Now, remember when we did average rate of change, and you had multiple points here. Okay, and basically we tried to get as close as we could to give us the best guess for the value at that point. So if I want to find what's going on at point Q, I would use this point right here to find out my average rate of change, right? It gives me the best estimate. And I want you guys to understand, we have all these secant lines here. Okay, as we get closer and closer and closer to this value right here, to Q, the secant line becomes really, really, really close, or pretty much the same as the tangent line. Okay, and then if it's the tangent line of that curve, we're actually at that point then. So this, once we get this tangent line here, that's the slope of that curve at that point. Okay, but the deal is, this value of H down here, math fans, this value of H right here, that has to get really, really, really small, right? That has to shrink. And so that's why, what are you going to think of? You're going to say, oh, as H approaches 0. So what we have finally is m is equal to the limit as H approaches 0, because that's our gap, right? The gap is getting smaller and smaller, so we actually get a value right on top of that point. Okay, limit as H approaches 0 of f of A plus H minus f of A all over H. This, math fans, is super important. Put some stars around here. We'll even change colors a little bit, but you got to put lots of stars around that, because that is a really important formula, and that is basically how you're going to find the slope of a curve at a point. Okay? Pretty easy. So let's actually use this now. All right, we'll start out with, here's your example. Find the slope of the curve y equals x squared when x equals 4, and find the equation of the tangent line and normal line. Okay, we've used the word normal before, but the word normal just means perpendicular. Okay, tangent line is what we're going to find, but normal line is just perpendicular, which is actually just going to be really easy once we have our tangent line. All right, so here's our function, y equals x squared, and here's my point that I'm looking at. So that x equals 4, that's my value of a. So a is equal to 4. So this is what I have. I have my slope of the tangent line, or the slope of the value at that curve, right, which is really the tangent line, is limit as h approaches 0 of f of, and if you look back at our formula, it's f of a plus h. So f of 4 plus h minus f of a minus f of 4 all over h. Okay, so I keep writing limit as h approaches 0. And then what I'm doing is I'm going to take that 4 plus h and I'm going to stick it right in that equation, right? That's it's really f of x equals x squared. So I'm going to put 4 plus h into x squared. And so I'm going to get 4 plus h squared minus 4 squared. Okay, again, I'm sticking the 4 into that x squared all over h. So I get limit as h approaches 0, and I'm going to FOIL that out. So I'm going to get 16 plus 8h plus h squared minus 16 all over h. Sweet, the 16's cancel out, which actually is really nice. Limit as h approaches 0 of 8h plus h squared over h. Remember, math fans, my goal here is to eliminate the denominator with the h, because I can't have that go to 0. Well, what can I do with this? Can I factor out an h? So 8 plus h over h, and then these guys cancel. Oh, that's sweet. Now I can do direct substitution, and so I say 8 plus 0, which equals 8. That's my slope at that point. All right, so let me just kind of draw it. If I would sketch it real quickly, this is y equals x squared, roughly, right? Vertex of 0, 0. And if I would actually go to x equals 4, that means y is equal to 16. So if I go, 1, 2, 3, 4, it's way up here. And don't you guys agree? As I'm getting steeper and steeper and steeper, what's happening to my slope? Well, it's actually getting larger, isn't it? It's getting more positive. All right, so just to kind of give you an idea of what's going on, I'm finding the slope at that point, and it's really of that tangent line. Okay, now this second part here, it says find the equation of the tangent line. That's really easy, math fans. You're given x equals 4. How do you find y? Just plug it back into the equation. Y equals x squared. So y equals 4 squared, which is 16. So your point really is 4 comma 16, and your slope is 8. Now, math fans, if you're given a point and a slope, and I ask you to find the equation, you put it in point slope form. Do not put it in any other form. In the AP exam, they will accept any form. So why take a chance of multiplying something wrong when you can you're just given that point and the slope, and you just put it in point slope form. So it's going to be y minus y1, so y minus 16 equals m, which is 8 times x minus 4. Okay, there we go. That's the equation. It's pretty easy. Now, what if I want to find the normal line? Well, again, if you had it in slope-intercept form, you would actually have to do figure out another value of b. But having it in point-slope form, it's so easy. It's literally y minus 16. I keep the same point equals, the only thing I change is that 8, I change it to negative 1/8 times x minus 4. It's really easy. So that's my equation, and this is for the tangent line, and this is for the normal line. Okay? All right, so let's do another example. It's something a little more complicated, because that was relatively easy. So let's do something a little more complicated here. Same directions. I want you to find the slope of the curve. Y equals 1 over 2x squared when x equals negative 3. And I want you also to find the equation of the tangent line, so the tangent and normal line, or lines. Okay, so the first thing we're going to do is we got to find that slope. So the slope is equal to the limit as h approaches 0, because again our gap is getting smaller and smaller. It's f of, remember, it's a, and a is -3. So it's -3 plus h minus f of a, or f of -3, all over h. Okay, so let's plug it into our equation. And guys, you need to keep writing this limit until you actually do the substitution. You always have to write limit. They're going to be looking for that in the AP exam. Very important you do that. All right. So we're going to plug that in. It's going to be 1 over 2 times -3 plus h squared minus 1 over 2 times -3 squared all over h. Okay, it looks a little nasty, but let's actually expand this out a little bit. Limit as h approaches 0 of 1 over, and I'm going to leave it the 2 on the outside. I'm just going to expand that -3 plus h. So it's going to be 9 minus 6h plus h squared minus 1 over -3 squared is 9 times 2 is 18. Okay, so I have limit as h approaches 0. Well, I'm going to multiply, I'll do it right here, at the top and the bottom, by 18 times 9 minus 6h plus h squared. And then 18, 9 minus 6h plus h squared. Okay, so what happens to the, let me, right over here, limit as h approaches 0. The 6, or the 2 cancels with the 18 to give you 9, and the 9 minus 6h plus h squared cancels also. So I wind up just getting 9 minus, and the 18's cancel, and I get parentheses 9 minus 6h plus h squared. Watch your algebra, okay? And on the bottom I get h, actually you get 18h times 9 minus 6h plus h squared. Okay, and let's distribute that negative on top. So I get 9 minus 9 plus h, or plus 6h minus h squared all over 18h 9 minus 6h plus h squared. Okay, that's nice. The 9's cancel, because then what can we do here? Well, we can factor out an h. So, and I didn't write limit here, which I should have. Limit as h approaches 0. I'm just running out of room here. So I'm going to actually cursor down here a little bit. And I'm going to get limit as h approaches 0 of, I'm going to factor an h out, h times 6 minus h over 18h 9 minus 6h plus h squared. Alright, that h cancels. Now I can do direct substitution because I don't have a 0 for a denominator. And I say 6 minus 0 is 6. And on the bottom I have 18 and basically times 9, right? Because the h goes to 0, and so we just have times 9. And what is that equal to? Well, I can simplify that. It's a 3, and that's a 1. So I have 1 over 27. That's the slope of that line at that point. Okay, at x equals -3. So that's the first answer. Now I want to come up with my tangent equation. Well, that's really easy. Let's go back to our original problem here, math fans. Right, x is -3. So what is y equal to? Isn't y equal to 1 over 2 times -3 squared, which is 1 over 18. That's y. So here's my coordinate, -3, comma 1 over 18. And my slope is 1 over 27. So if I put it in point slope form, I get y minus 1 over 18 equals the slope 1 over 27 times x plus 3. Alright, that's really easy. Point slope form, you're going to use that. So this is for the tangent, and of course for the normal, just as easy as y minus 8 or y minus 1 over 18 equals negative 27 times x plus 3. Pretty easy stuff, right? Not too bad. All right. Real quickly, math fans, your homework on problem number 13, you basically are given the function f of x equals absolute value of x. And I want you to understand that we really can't take that limit directly because the slopes are different on either side of the absolute value, right? If it's, if I sketched it and the graph looked like this, if it's on this side, you guys agree the slope is negative 1, and on this side the slope is positive 1. So what I want to do is I want to, for part A, they actually tell you at x equals 2, so you're not going to use that whole f of x equals absolute value of x. You're going to say, oh, x equals 2, and you're going to say, but f of x equals x, because we're in the positive part here. And then for B is x equals negative 3, that means f of x equals negative x. That's this part right here. All right, so kind of keep that in mind when you're doing the problems. You're trying to find the slope because you need to know what the line kind of looks like. All right, you can't just use absolute value. All right, the next one I want to talk about are piecewise functions. And here's a function for you. F of x equals 3x squared minus 2 when x is less than 0, and 5x minus 2 when x is greater than or equal to 0. And my question is, does the curve have a tangent at the indicated point? Okay, does the curve have a tangent at the indicated point? And you're like, well, wait a second, what point are we talking about? We're talking about where the two functions meet. Okay, at x equals 0. So there are two steps here, math fans, that you need to check to see if it is if there's a tangent there. The first step you need to do is, if I actually sketch a picture of a piecewise function, and I'm going to draw the slopes exactly the same. Okay, but does it have a tangent at that point? No, it doesn't, because there's actually a discontinuity there. Ah, discontinuity. Okay, so the steps, first step is you have to check for continuity. And math fans, this is like the easiest one to do. You would actually do this step before you do any other step, because it's easy to check for continuity. What do? You plug in this case here, plug in 0 into both equations. Okay, and that's going to tell you if it's continuous at that function. So sure enough, if I plug in 0, for the first one I get negative 2, and the second one I get negative 2. So this is continuous. All right, that's your first step. Your second step is, so I'll write that over here. This is your second step, is the left slope of a tangent is got to equal to the right slope of a tangent in order to be true. So again, going back to this just little graph I drew here, these slopes are the same. So we're going to have to check the slopes here and the slopes here on either side to make sure. So in other words, I'm checking it right over here and right over there, making sure the slopes are the same. Because here's an example where they wouldn't be the same, right? Here's a continuous function, and here's where the slopes are not the same. Okay, it's definitely continuous right here, but here's this slope is somewhat like that, and this slope is something like that across that line. So these slopes, m is not equal. Okay, so this one does not have a tangent at that indicated point. So what we're going to have to do is we're going to find the limit from both sides. All right, and so let's do that. We'll actually just cursor down here a little bit. And let me get my functions again. It's 3x squared minus 2, x is less than 0, and 5x minus 2x is greater than or equal to 0. Okay, so I'm going to kind of split this in half a little bit. And this is going to be my 3x squared minus 2. I want to see what's going on with that one, and I want to see my 5x minus 2, what's going on with that one. So I'm going to take the limit as h approaches 0, and since we're coming from the left-hand side, right, the gap is getting smaller from the left side, we can put a little negative here. And it's going to be f of, and of course it's h, and it's a, our value of a, is equal to 0. So h plus 0 minus f of 0. Okay, this is just what we learned. And basically what I do want to do is I want to plug that into my function here, that 3x squared minus 2. So it's going to be limit, and again, don't forget to keep writing limit as h approaches 0 from the negative side of 3 times h plus 0 squared minus 2 minus, in parentheses, 3 times 0 squared minus 2 all over h. So limit as h approaches 0 from the negative side. Okay, so that h plus 0, is that just h? So I really get 3h squared minus 2. That 3 times 0 squared is 0, so that's plus 2 over h. So that gives you limit as h approaches 0 from the negative side of 3h squared over h. So I can cancel that because that cancels, right? The 2's cancel. And 3h squared over h is just 3h. Now I have no denominator, and so what can I do? I can do direct substitution. Okay, so 3 times 0, and I get my slope is equal to 0. Okay, that's pretty mellow there, right? So that's what's going on at that point. My slope is equal to 0. And let's do the other side. Same thing, we're going to do limit as h approaches 0 from the positive side now, because we're coming from where x is greater than 0. And it's kind of the same idea, f of h plus 0 minus f of 0 all over h. So we're going to do limit as h approaches 0 from the positive side of 5 times h plus 0 minus 2 minus, and it's 5 times 0 minus 2, right? Plugging in the 0 all over h. So we wind up getting limit as h approaches 0 from the positive side of 5h, that cancels out 5 times 0, minus 2, minus 5 times 0, which is 0, plus 2, right? That gives you plus 2 all over h. Well, they cancel, and so do the h's, so I actually get my slope is equal to 5. So what can you tell me about that? These math fans are not equal. All right, these are slopes, the slopes of the tangent lines at that point, and those slopes are not equal. So the answer to the original question, if you go back to the original question, does the curve have a tangent at the indicated point? It does not have a tangent at the indicated point, which is x equals 0. Okay? So again, check for continuity first, then check for the slope of the tangent lines, and then you'll be good to go. All right, last thing here, just the other day, so yesterday we talked about average rate of change, and we actually talked about the velocity. Okay, and when we talked about velocity, that's the change in position over the interval of time. All right, and that was the average rate of change. And what I want to kind of propose to you now is that's our average velocity. What's going on? We're looking at, a value kind of right before the actual value I want, and we're taking the average of that. The closer we got to that, the better off we were. Well, now what I'm proposing is what happens when we get really, really, really close. So the gap approaches 0, or h approaches 0. just like our limits, right? So what happens is it gets closer. Don't you guys agree? As it gets closer and closer and closer, it doesn't really become, it's not kind of the average anymore. It's actually called our instantaneous velocity. Okay, that's really important. That's as h approaches 0. Okay, because we're getting really, really close to the point that we're looking at. All right, so before we do an example, I want to talk a little bit about speed versus velocity. All right, and some of you guys might know that from physics, but speed has a magnitude, and velocity has a magnitude and direction. So what I mean by this in just normal terms here, if I'm driving from my home to school, my speed might be 50 miles per hour. All right, and the velocity would also be 50 miles per hour. But if for some reason I couldn't turn around, I had to put it in reverse and come back to my home going in reverse, my speed would be still 50 miles per hour. So this value is always positive for the speed. But my velocity would actually be negative 50 miles per hour. Okay, so direction matters. It can go positive or negative, back and forward or reverse. Where the speed is, if somebody clocks me, the police officer clocks me going 50 miles an hour, whether I'm going in reverse or forward, it's still 50 miles per hour. That's why it's a positive value all the time. It just has a magnitude and not a direction. All right? All right, so let's do a nice little friendly example with instantaneous velocity. And let me give you guys, this is a good real life example. A Yox jumps with a rocket pack and at t seconds after jumps, the height is 2t squared plus 1 feet. So it's a function. And my question is, how fast is the Yox climbing after 5 seconds? Okay. Well, again, we're looking for our instantaneous velocity at that point. Okay, at 5 seconds. So that's our value of a. A is 5. So we're going to say limit as h approaches 0, our gap is 0, of f of h plus 5 minus f of 5. Okay, all over h. So that's limit as h approaches 0, and I'm putting that h plus 5 into the equation. So 2 times h plus 5 squared plus 1 minus 2 times 5 squared plus 1. And that's in brackets all over h. So again, this is kind of a matter of algebra. Calculus is actually pretty easy. It's just working everything out now. So that's going to be 2, and this is going to be h squared plus 10h plus 25 plus 1. And that's going to be 2 times 25 is 50, so minus 50 minus 1 all over h. Okay, let's keep going on here. Limit as h approaches 0 of 2h squared plus 20h plus 50, and then that 1's cancel and it's minus 50 over h. Okay, you can see things are canceling a little bit. the 50s cancel, and we have 2h squared plus 20h over h, so I can factor out an h. I could factor out a 2 also, but I don't really need to. So factor out an h, I get 2h plus 20 over h. The h's cancel, and now I can do direct substitution. So I put a 0 in there, I get 2 times 0 plus 20. So the answer to this problem is 20. And that's my velocity, so it's 20 feet per second. Okay, so that's pretty much how you find instantaneous velocity at a certain point. We're using the same thing. We're finding the slope of our tangent line because it's kind of what we did yesterday with looking for the average rate of change and finding velocity, right? So that's it, math fans. That's you learned actually a pretty important concept here with finding the slope of a tangent line and also finding instantaneous velocity. All right, math fans, have a great day. Adios. Goodbye.